known as a Prayagraj, a city known for its historic intellectual culture and the academic excellence of several of its residents, and completed her PhD from our very own university, University of Delhi. Her academic excellence over the years has been greatly appreciated. She remained a profoundly meritorious student, competing and excelling from the school days all the way to her PhD. A person with strong a person with strong feminist dispensation, she believes that education is the strongest tool for empowerment of women. She pursued science as a career option, specifically keeping in mind the participation of women in STEM has been considerably less than men in our country. She did her graduation from Muir Central College, Allahabad, MSc from the Department of Chemistry from the Allahabad University, and the PhD from the Department of Chemistry, University of Delhi in 2002. Her thesis is titled as Corrosion Inhibition of Mild Steel by using some phosphonium compounds in acidic medium. Like moving further, her field of specialization is inorganic chemistry. Arkaza ma'am has been teaching for almost 20 years in the Shamlal College with a brilliant annual performance appraisals reports of her teaching both in the classroom and the lab in the period from the 2004 to 2024. Ma'am has organized and attended multiple seminars like the National Seminars on Chemical Weapons Conventions, contributed to several conferences, and written articles on not just core chemistry related topics but also on convergence of the modern sciences and ancient wisdom like homotherapy. Sorry. She has more than 25 publications in prestigious journals and a PhD student working under her guidance. Ma'am has excelled in teaching, leadership, mentorship, administration, and more. She is strong believer in the holistic education of sciences, and for that she believes that students should know the history of science too. Ma'am, who is an associate member of the Royal Society of Chemistry, London, has, has herself traveled to several places in the world associated with history of the stamp. She visited Khiva in the Central Asia, birth of the famous scientist Muhammad ibn Musa al-Khwarizmi. The term algorithm still remind us of him. Several medieval scientists in Central Asia studied in this city, and ma'am visited the college where they studied to learn about them. In Europe, she visited the birthplace of Albert Einstein in Germany and saw the spot where flight pioneer Albert Berglinger, called Sander von Ulm, did his experiments. She strongly believes experiential learning in the best form of learning. Apart from academics, ma'am has also held several leadership roles. She became the convener of the Student Union Advisory Committee in 2014, head teacher in charge of the chemistry and the environmental studies in 2015, founder of the Debating Society, member of the governing body and the grievance redressal cell and the NAC steering committee and selection committee. She also convener of the admission committee and the moderation committee. Ma'am also participated as member of the policy recommendations committee in present government. In the last, I will talk about ma'am has actively participated in many events such as Vigilance Awareness Week, debating quiz, display of the food practices in the from the Central Vigilance Commission as the organizer, and also ma'am participated in event World Cultural Festivals from the Ministry of Culture. The Business of the Change Agenda 2030 Sustainable Development Goal and Information Center for India and Bhutan. So now I am give the warm welcoming to the ma'am for the next like online poster session. Please welcome ma'am. Thank you very much.
for the online presentation of.
Okay.
अभी उसमें
For session 2 that is happening in multi-purpose hall, the poster presenters are Dr. Prem Prakash Tripathi, followed by Navam Tayum, Dr. S.K. Verma, Rishi Raj, Piyush Kumari, Mahadev Varshney, and Tanvi Yadav. So we'll start taking up from Dr. Prem Prakash Tripathi. I request the technical staff, if Dr. Prem Prakash Tripathi has joined, please make him co-host.
प्रेम प्रकाश जी कोई नहीं है
SBS Government PG College, Rudrapur.
स्क्रीन देखो ना आप स्क्रीन पे
Dr. Prem Prakash Tripathi, if you are able to unmute yourself, please unmute yourself. Have you joined? We want to know.
नहीं है
Dr. Prem Prakash Tripathi, the session 2 is happening in multi-purpose hall. The list has already been shared the day before yesterday. The next poster presentation is of Navam Tayum from Northeastern Region Institute of Science and Technology,
वो भी नहीं है
Itanagar, Arunachal Pradesh.
नहीं है
Have you joined? The link has been joined by these people or not? Then? Okay. Now Dr. S.K. Verma,
नहीं है
Bikaner. Dr. S.K. Verma, Rishi Raj,
नो
if the poster presenters from session 2 are able to hear me, please join the respective link. Session 2 poster presenters, I request you to kindly join the link, the Google Meet link.
मैंने जूम लिंक
Anyone from Dr. Prem Prakash, Navam Tayum, Dr. S.K. Verma, Rishi Raj, Piyush Kumari, Mahadev Varshney, and Tanvi Yadav.
जूम लिंक क्या था गूगल में हाँ ओपन ही नहीं है गूगल वो गूगल मीट खोलने का गूगल मीट पड़ी है जूम लिंक की तो भाई मैडम को मैं बोल रहा हूँ ऑनलाइन नहीं कर हाँ फिर ठीक है फिर ठीक है
ये मैं बता रही हूँ
ना गूगल मीट का कॉन्फ्रेंस है सर एक अंकित सर की
किसने बनाया था
तो कॉन्फ्रेंस के आईडी देखो तो कॉन्फ्रेंस आईडी का और इसी से बनाया आईडी पासवर्ड
मैडम एज अ गेस्ट ज्वाइन करेंगे ना इसमें अच्छा
कॉन्फ्रेंस आईडी से लॉगिन करोगे तो ऐसे पोस्ट ही जाएगी ये रहा आईडी पासवर्ड
जीमेल करना पड़ेगा
CCTCS SLC
किसके फोन में होना है OnePlus 10R 5G वो फॉलो करेंगे तो ठीक है
अंकित 38 नंबर टैप करो वो आप काम करो ईमेल करो और नहीं हमारा सबकी आईडी को फोन में
मुझे कोई दिक्कत है मैं तो बैठा हूँ That's very like अभी तक तो नहीं शेयर नहीं होता
एक फाइल ऑलरेडी शेयर्ड है मुझे सर उसको ऑलरेडी
ऐसा होता है एक्सपायर हो जाता है तुम्हारा नेट बन जाता है जब तक आप अपडेट नहीं करोगे तब तक send it 20
Send सेशन के लिए करेंगे ये दौड़ के जिनके साथ बिजली नोटिस कर दिया ना डेटा नाम कॉन्फ्रेंस आईडी से वो शेयर को वैसे नहीं कर सकता सबको शेयर कैसे करेंगे अगर ये हो जाए तो बेटर है ना जितना बनाएंगे उतने में तो हो ही जाएगा जो भेजेगा ना
भेजो
ग्रुप
मैं।
में हाँ,
भेजो मैं।
सर, क्या नाम है ये?
हेलो
क्या बोल रहे हैं? देखिए नया लिंक बनाया
70
नहीं नहीं
70 70 70 70 70 है करो
70 तो ठीक है
आ जाएगा फिर another 65
यस यस
65
ताकि वो एक्सपेंड कर रहा है नंबर्स पे नहीं आ रहा करेक्ट करेक्ट
ठीक लग रहा है
यहाँ पे सबको उसमें ग्रुप में डाल दिया ना सबको ऐड करवा दो सबको
कैमरा
यहाँ पे सबको अलाउ कर दो जो भी है यहाँ पर तुम्हारा नाम बोलो
Mr. Prem Prakash Tripathi, Nabam Tayum, Dr. S.K. Verma, Rishi Raj, Piyushi Kumari, Mahadev Varshne, and Tanvi Yadav. Have you all joined?
Yes,
Mr.
ma'am.
Prem Prakash. Mr. Prem Prakash. Nabam Tayum. S.K.
Yes,
Verma,
ma'am.
Dr. S.K. Verma. Mr. Rishi Raj.
Yes, ma'am.
Piyushi Kumari.
Present, ma'am.
Madhav Varshne.
Yes, ma'am.
Tanvi Yadav.
Yes, ma'am.
I think then we should start. Please start presenting your screen, Mr. Prem Prakash Tripathi. Prem Prakash Tripathi, are you there? So moving further, the Nabam Tayum.
Yes, ma'am. I am present, ma'am. My
Uh,
PPT is ready, ma'am.
Okay, okay. So now you can start.
Okay, ma'am. Thank you.
बनाना तो नहीं बनाना पड़ता है
मैं तो
Oh, sorry.
देखिए लैपटॉप तो मेरे पैटर्न का बहुत बड़ा है।
Hello, is this visible to you, ma'am? Hello?
Yes, yes, it's visible.
Okay, thank you, ma'am. First of all, good afternoon, everyone. So, myself, Mr. Natnavam Tayam, PhD scholar from Northeast Regional Institute of Science and Technology. Today I'm going to present is about theoretical study and decomposition pathways of ethyl propionate radicals. So this will be my content, general introduction and computational method and research and discussion and IRC graph and PS energy diagram, conclusion and acknowledgement. So let us see the introduction portion. So this molecules is it is obtained from the animal fat here and vegetable oils, and it is before it was these molecules used as a first generation biodiesel, and because it has similarities in physical properties. And these molecules, when released into the environment, these molecules, when released into the environment, it's may harmful for the environment. Since this is a radical species. Radical species are very reactive and highly unstable in nature. And this is the reaction schemes. TS1, this is the decomposition pathways of this radical. This is a TS1, TS2, TS3, TS4. This is the state of these molecules in the presence of oxygen. That is called oxidative pathways. And computational method. I have used the Gaussian 9 software, and all the optimization work has been done under the Gaussian 9 software with the help of DFT calculation. And M06 is my DFT basis state, M0628, and I can 61 GP. And I have done frequency calculation and the IRC calculation has been done. And Gaussian software, I have run these molecules, and all the views has been done in the Gaussian view. And after getting the optimization for the I draw the diagram in the with the help of GameCraft software. And GameCraft software, and this is my result and discussion. And we have calculated the reaction interface and free energy calculation. All things have done in the with the help of Gaussian software only. I obtain delta G value and delta H value. This is a free energy enthalpy, and delta H for enthalpy of the reaction. And frequency value there has one negative value, that is called imaginary frequency, and other all the remaining transition state value will be positive, because of the transition state is a place where the intermediate between the both the reactant and product, in between that region is transition point. Again, we further extend the presence of the saddle point and intrinsic reaction coordinate calculation was carried out at the same level of theory, and clearly authentic and smooth transition from the reactant to product along with the potential energy surface cycle. Single point energy calculation has also been done at the M06 2x level. And this is the optimization molecules. This is the optimization. The optimization means most stable point of this molecule. This is the optimized molecule. And this is the one diagram is IRC calculation. Sorry. Slide please. This is the IRC slide diagram. This is one is for TS1, TS2, TS3. TS means transition step. TS1, these all are the stable point of view. With the help of PS diagram, with the help of IRC diagram, we can able to identify whether our reaction is reactant to product is formed or not. With the help of IRC diagram, we can able to identify the molecule as formed or not. And this is the another one is the energy level diagram. After the rigorous calculation of energy value, then we can able to show the energy level diagram of the each transition step. And conclusion, with conclusion, oxidative pathways and decomposition reaction pathways, thermodynamic chemistry and kinetics of these molecules as per the ethyl propionate we have done in the Gaussian software as DFT method. And then this method has so many methods, and we have obtained energy values. And I have published this paper on the Taylor and Francis in the book Molecular Emulation in the year of 2023. And thanks to the environment for future generation, and thank you. Thank you, ma'am.
Okay, thank you, Kayum.
Thank you, ma'am. Thank you.
Next, Dr. S.K. Verma. Sir, are you there? Dr. S.K. Verma from Bikaner Government College. Dr. S.K. Verma. Okay, now moving further. Rishi Raj.
Yes, ma'am.
Yeah, are you there?
Yes, ma'am. Yes.
Okay, you have the 5 minutes. Make it fast. Okay.
Okay, ma'am.
Please start.
Is it visible?
Not yet. Did you share the slide?
Yes, ma'am.
No, it's not visible yet.
Not visible to us.
Not visible. Is it visible now?
Yeah, it's visible. It's visible.
Good afternoon, everyone. So my topic is catalytic properties of TiO2 nanofibers in CO2 conversion. So starting with the introduction, I say that the nanofibers of TiO2 emitted in different polymer area as a CO2 conversion catalyst.
Hello,
So as you can see that. Hello. Yes.
Can you please little zoom it? So.
Yes, sir. This is
Yeah.
Now is it?
Okay. Fine. Thank you.
So talking about the introduction, excessive use of fossil fuel leads to its depletion and leads to CO2 emission and affecting our environment. So effects can be like supercharging of natural greenhouse effect, causing global temperature to rise. So we are using TiO2 as a potential catalyst. It has excellent optical and electronic properties, high photocatalytic activity, high chemical stability, low cost and non-toxicity. So this is the materials and methods required here. So we are using PIP, ethanol, acetic acid, and here we are considering two polymer matrices, that is PVP and PVDF. And method we are using is the electrospinning method. This is the instrument, and this is the drum collector with the TiO2 fibers. So this is a graphical representation where the nanofibers are made and collected on the drum collector, and here CO2 is converted into ethanol and methanol. So these are the resultant discussion of our research. These are the XRD images of both the PVDF and PVP. These are the same images. And talking about the discussion, diffraction patterns of where we can see that PVP and PVDF exhibited characteristic peaks that correspond to the anatase phase of TiO2. So the major diffraction peaks observed were at, you can see that 25.3, 37.8, 48, 54.2, and these were the peaks of the observed. So PVP, a hydrophilic polymer, it forms a stable and compatible matrix for TiO2 nanoparticles due to its high solubility in water and various inorganic solvents. The interaction between PVP and TiO2 facilitates the prevention of particle agglomeration, promoting higher surface area and active sites available for photocatalytic reactions. So in this conclusion, we can say that PVDF is a semicrystalline polymembrane for its hydrophobic nature, providing a different type of support to TiO2 nanofibers. So now the conclusion here, it is clear that a thorough investigation on synthesis procedure, characterization methods, and performance assessments that these nanofibers have a great deal of promises in the environmental sustainability. We can use through efficient use of this solar energy and the conversion of CO2 into useful products like methanol and ethanol. These materials present a viable way to reduce greenhouse emissions. So the large surface area to volume ratio of PVDF improves TiO2 nanoparticle immobilization and dispersion. This property maximizes the exposure of active site for CO2 absorption and conversion, facilitating the photocatalyst efficient use. So which it improves the efficiency of CO2 conversion as well. Overall, PVDF, unique blend of high surface area, optical transparency, mechanical robustness, and its processing ability, TiO2-based photocatalysts are the best for CO2 conversion, which provides the scientific justification for the support. This study lays the path for more innovation in CO2